going to be talking about measuring the center of quantitative data. All right, so we're going to be able to find and interpret the median of a distribution of quantitative data. Also, we're going to be calculating the mean of a distribution for quantitative data and comparing these two for a distribution and choosing the more appropriate measure. So the vocab includes the median, mean, and the word resistant. All right, so in the previous lessons, we approximated the center in the graphs that were constructed in the other lessons. So for example, dot plots, stem plots, and histograms when we were doing quantitative data. So we only kind of guessed where the center was. This time we're going to be able to calculate the center. So the two most common measures ways to measure the center are the median and the mean. So for the median, we can actually report the value in the middle of a distribution, which is, its center, and we call this the median. So the median is the middle value. So if we were to define the median, it is the midpoint of a distribution, the number such that about half of observations are smaller and about half are larger. So to find the median, arrange the data values from smallest to largest. So the median is the midpoint or the middle number in a set of data, as long as the numbers are sorted. So if the number of data values n is odd, then the median is the middle value in the ordered list. However, if the number of data values is even, the median is the average of the two middle values in the ordered list. So let's look at an example. So here are the data on the amount of fat in grams in 9 different fish and chicken sandwiches on McDonald's menu in 2014. Find the median. Interpret this value in the context. So what we want to do is sort the values from smallest to largest. And then notice that there are 9 values here, and 9 is an odd number. So therefore, the median is going to be the middle value in the ordered list. So we're going to have to sort the data from smallest to largest. All right, so if we go ahead and do that, we get these numbers from 9 to 33. So now what we need to do is we need to cross out the number from the left and the right and work our way towards the middle. So starting at these two numbers, we're going to work our way towards the middle. So I like to do a count. So this is 1, 2. Then the next one is going to be 1, 2, 1, 2, 1, 2. So now I'm done. And notice that the number 19 is left in the middle between those two arrows. So the 19 is actually the median. So the median is 19. So this means that about half of McDonald's fish and chicken sandwiches have more than 19 grams of fat, and about half have less than 19 grams of fat. So if we were to plot this in a actual dot plot, we can work our way towards the center to find the median. So notice that the 9 and the 33 are circled, and we're going to work our way towards the middle. So then those are the next two numbers, then the next two numbers, then the next two numbers, and then the last dot that is stacked is actually the median, which is, notice that it's at about 19 grams. So this is another way to find the median if you're given a dot plot. So let's look at another example. Another set of sandwiches from McDonald's 2014 menu. This time these are 12 different beef sandwiches along with the dot plot. So we want to find and interpret the median. So again, sort the data from smallest to largest. And notice that there are 12 data values here, which is an even number. So that means we're going to have to average the middle two values in the ordered list. So down below is the ordered list from 8 to 40. So starting from 8 and then at 40, we're going to work our way towards the middle. So we got 11, 1, 2, 1, 2, 1, 2. So notice that we got two values left. So those are the two middle values. And therefore, we're going to have to take those two values and we're going to have to do the average them, which means that we're going to have to add them up and then divide by 2. So if you do that, you get 48 divided by 2, which is 24. So therefore, our median is 24. This means that about half of the McDonald's beef sandwiches have more than 24 grams of fat, and about half have less than 24 grams of fat. All right, so let's talk about the mean. The mean is actually the most common measure of center. So if we want to define the mean, x bar, so this is how you pronounce the symbol with the bar on top of it. So the mean x bar of a quantitative data set is the average of all n data values. To find the mean, you simply add all the values and divide by n. So very simple formula. So you sum up the data values and then you divide by the total number of data values. Now there's a better way of writing this using symbols. So instead of writing all these words, what we could do is we can actually use symbols to shorten this. So if the data values are given by, say, x1, x2, dot, 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 all the way to xn, where n is the number of observations, then we can write the formula for the mean as such. So x bar is equal to, so now you can add up your data values, x1 plus x2 all the way to xn, divided by the total number of data values, which we call n, and it's equal to this fancy symbol, and this symbol is actually the Greek letter capital sigma. So that symbol is capital sigma, and all it means is to add all the data values up. So sigma means summation. The n stands for the total number of observations. Okay, so that when you see that sigma symbol, just think it just means add the data values together. So it's a shorthand. So now the notation x bar actually refers to the mean of a sample. If you wanted to find the mean for a population, then you're going to actually use the symbol mu. So that symbol is the Greek letter lowercase mu. And let's talk about quickly what a sample is. So a sample is actually a subset of a population. And the population includes every single person that you're studying. A sample is just part of that population. Most of the time when we collect data and statistics, it is from a sample. It's not from every single person in the population. And therefore, most of the time we will be using x bar. However, sometimes you will be using a population, and then if you were to use the mean of the population, we would use the symbol mu instead. All right, so let's look at an example of the mean. So it's asking, how many runs does the Lawrence High School baseball team usually score? Here are data on the number of runs scored by the team in all 21 games played during a recent season, along with a dot plot. All right, so the first part, they want us to calculate the mean number of runs scored per game by the team during the season. So in order to calculate this, we need to use the formula for the average, or the mean. So you simply add all the numbers up together and then divide by the total number of observations. In this case, we had 21 games. So in this case, if you add them all up, you get 87 divided by 21 games, or 4.14 runs per game. Pretty simple, just do the average. Part B, the dot plot suggests that the game in which the team scored 12 runs is a possible outlier. Calculate the mean number of runs scored per game by the team in the other 20 games this season. What do you notice? So we're going to remove the 12 games from the calculation, and we get this. So notice that there's no 12 games, it ends at the 10 games. And now we have 20 games, so 20 is in the denominator. So in this case, we have 75 divided by 20, which is 3.75 runs per game. So then notice that the 12-run game increased the mean number of runs scored per game by 0.39 runs. So this means that the mean changed when we added that extra observation in. All right, so notice from the previous example that the answers to part A and B were different, 4.14 as opposed to 3.75. So this actually shows an important weakness of the mean as a measure of center. This is showing that the mean is actually not a resistant measure of center. And what do we mean by that? So the definition of resistant is a measure of center or variability is called resistant if it isn't influenced by unusually large or unusually small values in a distribution, also known as outliers. So being resistant means that you're not really being changed very much if you remove any outliers, or if you remove any certain values that are extreme. So on the other hand, the median is a resistant measure of center, whereas the mean is not. So take a look at this example. So this is the example from the data that we just used. So notice that if you were to do the median of this distribution, you would get 3. Now, assume that we remove the 12 from the distribution, assuming that it's an outlier of some sort. Let's say we want to remove it. Okay, so now we removed it. Now let's calculate the new mean, median rather. So if you calculate the median of this, well, you're going to have the two middle numbers. And if you add them up, divide by 2, you're still going to get 3 as the median. So basically, this shows that the median doesn't change much, if at all, even when removing outliers. However, if you were to calculate the mean and remove the outlier, the mean will change a lot. All right, since the mean and the median change, which one do we use? So given a set of data, you will usually have to report a specific value as the representative measure of center. So how do we decide? The decision to determine which measure of center should be reported depends on the following two things. So it depends on the shape of the distribution as well as the presence of outliers. So let's take a look at the following examples. So we got three distributions, three dot plots essentially. And what we want to do is we want to show how the mean and median change. So notice that the left dot plot is a graph that is skewed to the left. Notice that the mean is almost 18 here, whereas the median is 19. So this means that the mean changed a lot because of the fact that the graph was skewed to the left and the mean was pulled towards the left. If you look at the roughly symmetric distribution, the mean is about the same as the median. If you look at the skewed to the right distribution, normally the mean would be in the middle with the median. However, it got skewed to the right. It got moved to the right or pulled to the right along with the longer tail. So this is showing you that the mean is not very resistant to outliers. So notice the shape first. The mean is pulled in the direction of the longer tail in skewed distributions, but it is around the middle at the median for symmetric distributions. As far as outliers are concerned, the mean is sensitive to extreme values, and therefore we call it's not a resistant measure of center. So if you look at the two new graphs above, if we have an outlier, the mean becomes 22.52. However, if we remove the outlier, the mean becomes closer to the value of the median, because now the distribution is approximately symmetric. All right, so let's look at an example. In the beginning of the lesson, we represented data on travel times and minutes of 20 randomly chosen New York workers. So here's a dot plot of the data. Explain why the mean is so much larger than the median. All right, well, notice that the graph is actually skewed to the right. So therefore, the mean is being pulled towards the longer tail in the right skewed distribution. Another way of thinking about it is that the outlier of 85 minutes inflates the mean and makes it larger, while it doesn't affect the median as much. So which measure of center better describes a typical travel time to work? Well, if we look at the mean of 31.25 minutes, it doesn't reflect a typical travel time. The reason is because if you use this as the center, only 7 of the 20 New Yorkers reported travel times that are 31.25 minutes or longer. And 7 out of 20 is not half of the distribution, so that's not the center. Therefore, if you look at the median of 22.5 units better summarizes the distribution because the travel time is skewed to the right and has a possible outlier. So essentially, if you have skewed distributions, you tend to want to use the median to represent the center of the data because the median is resistant to outliers. If you have a roughly symmetric or completely symmetric distribution, then you can get away with reporting the mean as the measure of center because the mean is going to be approximately the median. All right, go ahead and try the problem, pause it, and try it first. All right, so here are the travel times in minutes for 15 workers in North Carolina, chosen at random by the Census Bureau, along with a dot plot of the data. So find the median, interpret this value in context. Calculate the mean travel time, show your work. Which measure of center, the median or the mean, better describes the typical travel time to work for this sample of workers in North Carolina? Justify your answer. All right, so we went and copied the distribution so that we can reference it. So first, if we want to find the median, we have to actually sort the data from smallest to largest. So this is what we did down below. So now, if we want to find the median, work your way towards the middle, starting from the extremes. All right, so starting on 5 to 60, work our way towards the middle. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So now we got the middle number of 20, and that is going to be our median. So in this case, the median is 20, which means half of the workers in North Carolina have a travel time less than 20 minutes, and half have a travel time greater than 20 minutes, or equal to. How do we calculate the mean? Well, we're going to use the mean formula, which means we're going to add all the numbers and then divide by the total number of observations. In this case, we have 15 travel times. So we add them up to get 337 divided by the number of observations, 15, and we get 22.5 minutes. All right, so then because the distribution is actually skewed to the right, the outlier of 60 minutes pulls the mean towards the right, which means that it is not an accurate measure of center for the data. So the median would be more appropriate as the measure of center for this distribution. All right, so to summarize the data, we mentioned that there are two measures of center in this lesson that we discussed. So the two measures of center that we discussed are the mean and the median. The median is actually the midpoint of the distribution, so the exact middle number. There are two cases for the median. If there are an odd number of observations, then the median is the middle number in the sorted list. If there are an even number, then the median is the average of the two middle numbers in the ordered list. Mean, on the other hand, is the average of all the observations. So we add them up and divide by the total number of numbers. The median is a resistant measure of center, whereas the mean is not resistant. So the guideline is, for skewed distributions, the median is a more reliable measure of center. For roughly symmetric distributions, the mean is a more reliable measure of center. All right, in the next lesson, we're going to be talking about measuring variability in a set of quantitative data.